Hello my friends, welcome to my channel Math and Stuff with Samson Paul. Today in my first video I'll be discussing with you guys one of my favorite topics in integration, and that is nothing but integration by parts. It's a very easy topic and it's a very likable topic, and that's why I'm going to discuss this first. Now, what is integration by parts? So there are a lot of methods to solve integrals, indefinite integrals, but when we find it we cannot derive an integral into its basic form, then we use integration by parts. Okay, and in a minute I'm going to discuss this formula for you here on integration by parts, and the formula for integration by parts is this formula here. Okay, so if you have integral u dv, it is equal to uv minus integral v du. For now, let us consider this as indefinite integrals. So I write it as IDI, indefinite integrals. There are no limits. Okay, let us not get into that stuff now. Maybe in a future video I will show that how to evaluate definite integrals, but for now let us review this formula. Integration of u dv is equal to u into v minus integral v du. Now if you have a function and you can't reduce the function, how can you choose u and dv? Okay, one might ask you, how can you choose u and dv? And there is a general rule for that, and the rule is called I-late rule. Okay, I have made it I-late rule because it's easy to remember. I-late. Some books or some methods also consider it as L-I-A-T-E rule. So Lee-8 rule. Okay, basically what I'm trying to tell you is, if you interchange these two functions, if you take by mistake these two functions in this function, basically when I'm talking what to take as u and what to take as dv, if you take u as t and dv as e, it's fine. Okay, but even if you take u as e and dv as t, still you will get a solution. So these two functions are interchangeable: inverse and logarithmic, and trigonometric and exponential. We can exchange them and still get the answer. But for other functions, if there are all these functions existing, you must follow this rule. The inverse function has the first preference, logarithmic has the second preference, then comes algebraic, then comes trigonometric, and the last comes exponential function. Exponential function stands for e power functions, e power x or other e power functions. So I'm going to solve one example explaining how to solve this. It's a very simple example. Let us start with simple example. The example is x sine x dx. Now clearly this function is not reducible in any way. You cannot reduce this function in any way. There is no reduction. You cannot factorize it, or you cannot do anything to this function before solving it. So in these cases you are supposed to use integration by parts. Now which one would be my first function? I have to follow this order, top to bottom, I-late rule. The first function is nothing but u. Now what to choose as u? In this case my u is x, because algebraic has higher preference over trigonometric functions. So my u is x and my dv is sine x dx. Please remember, do not forget dx. Please, you can include sine x dx. So my u is x and my dv is sin x dx. Okay, after this it is basic application of the formula. You have you have dv. Okay, then you are supposed to get uv. How do I get u and v? To u, you have already got u is equal to x you have taken. Now from u, if you are supposed to get v, du, all you have to do is differentiate with respect to x, du by dx with respect to dx by dx, which is 1. And you can see that du by dx, du is equal to dx. Okay, this is very important. You have to find out all the variables which you do not know. You know u, you know v. You do not know v, you know dv. Okay, so your next step is to find out v. How to find v? To find out v, you take dv as integral sin x dx. Okay, or dv is sin x dx, and integrate it, or take the antiderivative of it. When you take the antiderivative of this, integral dv is equal to integral sin x dx. Okay, you get v is equal to minus cos x. One might ask me why there is no constant of integration, because these are indefinite integrals and there is no constant of integration here. Now we could include that constant of integration as same limits. So since these both, in case the limits used to exist here, we should be sure that both of them will have same limits. So in that case, both these variables will give a same c value, and that can be cancelled on either sides, and you can get v equal to minus cos x dx. Okay, then it is direct substitution. Okay, substitution, we write u integral of x sin dx is equal to x, and we want v, that is minus cos x, minus of integration sign, which is here, minus cos x, that is the integration of v that we have got here, v integral minus cos x, and of course in the end du, which is nothing but dx. Okay, so now we have the function answer here, that is minus cos x. Okay, and I have taken this negative sign outside, which becomes positive. Then we are left with integral of cos x dx, which is nothing but sin x. Okay, and I substitute it as sin x plus c, and this is my answer. Okay, thank you for listening. Have a good time with math.